In the bustling streets of Mexico City, millions of people carry within their blood the echoes of ancient empires that rose and fell centuries before Europeans arrived. But beneath the surface lies something even more extraordinary. Every Mexican alive today carries DNA that tells the story of one of history's most dramatic collisions, the moment when three separate continents converged in a single land, creating genetic combinations that had never existed. Today, we're going to unlock that puzzle. We're going to reveal what scientists have discovered when they analyzed Mexican genetics using the most advanced DNA technology available. When the Spanish arrived in 1519, they encountered something unprecedented: dozens of thriving indigenous civilizations with their own unique genetic signatures. Then something remarkable happened. Over the next 300 years, a complex social system emerged that would accidentally create one of the most genetically diverse populations in human history. The Spanish colonial caste system became a detailed classification system that tracked and controlled how different genetic lineages mixed together. Think of it as an unintentional genetic experiment spanning centuries, involving millions of people. Mexican DNA today carries genetic markers from 3 different continents. It tells the story of indigenous peoples who survived ice ages, Spanish explorers who crossed oceans, and African populations who endured forced migration. This is the hidden history living inside Mexican blood. And once you understand it, you'll see why Mexican genetics hold keys to understanding human adaptation, survival, and the incredible complexity of our shared human story. To understand the complexity of Mexican DNA, we must first examine what existed before 1519. What scientists have discovered about pre-Columbian Mexico challenges everything we thought we knew about ancient populations. For thousands of years, Mexico was home to one of the most genetically diverse collections of human populations on Earth. When researchers analyzed DNA from indigenous populations across Mexico, they uncovered a shared ancestral signature that connects these peoples to one of humanity's greatest migrations. The paternal lineage known as haplogroup Q-M3 appears in over 90% of indigenous Mexican populations. This genetic marker serves as molecular proof that their ancestors undertook an epic journey across Beringia during the last ice age, eventually populating 2 entire continents. Yet within this shared heritage lies remarkable diversity. Over millennia, geographic isolation created distinct genetic signatures in different regions. The Maya of the Yucatan Peninsula developed different maternal lineage frequencies than the desert peoples of the north. Each environment acted as a natural laboratory for human genetic adaptation. Trade networks spanning from the Pacific to the Gulf of Mexico facilitated periodic genetic exchange between groups. Archaeological evidence shows extensive commerce in obsidian, jade, and cacao that connected distant populations. Marriage alliances between ruling families created genetic bridges across political boundaries. The rise and fall of empires like the Toltec and Aztec brought together diverse populations under unified political systems. By the early 1500s, a genetic landscape of extraordinary sophistication had emerged. Dozens of distinct populations, each carrying the molecular memory of ancient migrations, environmental adaptations, and cultural innovations. But the arrival of European ships would transform this ancient genetic landscape forever. In February 1519, 11 Spanish ships appeared off the coast of what is now Veracruz. Aboard those vessels were 508 men who would inadvertently trigger the most dramatic genetic transformation in human history. With them, they carried invisible agents of biological warfare that would reshape the genetic landscape of an entire continent. The demographic collapse that followed represents one of the most severe population bottlenecks in recorded human history. Smallpox arrived first, spreading through indigenous communities with devastating efficiency. Measles followed, then typhus. These diseases moved faster than Spanish armies, penetrating deep into territories that Europeans had never seen. Conservative estimates suggest that 90% of Mexico's indigenous population perished within a century of contact. Entire genetic lineages that had survived ice ages and volcanic eruptions simply vanished. Communities that had maintained distinct cultural and genetic identities for thousands of years disappeared within a single generation. The genetic diversity that had accumulated over millennia was reduced to scattered survivors in remote regions. But the Spanish conquest involved more than epidemic disease. It introduced a completely foreign genetic component to the Mexican population. The conquistadors were predominantly male, carrying European Y chromosome haplogroups that had never existed in the Americas. Haplogroup R1b, common throughout Western Europe and the Iberian Peninsula, began appearing in Mexican bloodlines for the first time in human history. The demographic mathematics of conquest created an unprecedented genetic scenario. Spanish men, arriving without European women, formed unions with indigenous women who had survived the epidemic catastrophes. This pattern would define Mexican genetics for centuries to come. The maternal lineages remained predominantly indigenous, while paternal lineages shifted dramatically toward European origins. This was not merely cultural conquest, but biological transformation on a continental scale. Each child born from these unions represented a new genetic combination that had never existed before. The mestizo population emerged not from gradual cultural exchange, but from the collision of two completely separate evolutionary histories. The African component of this genetic transformation began in the 1520s, when Spanish colonial authorities started importing enslaved populations to replace diminished indigenous labor forces. These individuals carried Y chromosome haplogroup E1b1a and maternal haplogroups from the L lineage, genetic signatures originating in sub-Saharan Africa. Though numerically smaller than European immigration, African genetic contributions would become permanently integrated into Mexico's emerging population. By 1600, Mexico's genetic landscape bore no resemblance to what had existed just 80 years earlier. The ancient indigenous foundation remained, but it was now overlaid with genetic material from two additional continents. Three separate human evolutionary histories, separated by thousands of years and vast ocean distances, had been forcibly combined in a single geographic region. By the early 17th century, Spanish colonial authorities faced an unprecedented administrative challenge. Mexico's population now consisted of genetic combinations that had never existed before in human history. The traditional categories of Spanish, Indigenous, and African proved inadequate for classifying a society where genetic mixing was becoming the norm rather than the exception. The Spanish response was the creation of the most detailed system of human genetic classification ever attempted. The caste system emerged as a comprehensive bureaucratic framework designed to categorize every possible combination of ancestry and assign specific social, economic, and legal privileges accordingly. At the system's apex stood the peninsulares, individuals born in Spain with documented European ancestry. Below them were the criollos, people of Spanish genetic heritage born in the Americas. These two categories controlled the highest levels of government, commerce, and religious authority throughout colonial Mexico. The system's complexity lay in its treatment of mixed ancestry. Mestizos, individuals with Spanish and indigenous genetic heritage, occupied a carefully defined middle position. Mulattos, with Spanish and African ancestry, were placed lower in the hierarchy. Zambos, with indigenous and African genetic combinations, found themselves near the bottom of the social structure. But the caste system extended far beyond these basic categories. Spanish bureaucrats developed over 16 distinct classifications, each representing specific genetic combinations and their perceived social value. Castizos emerged from mestizo and Spanish unions, theoretically moving closer to Spanish genetic purity. Moriscos resulted from mulatto and Spanish combinations. Each category carried precise legal implications for marriage rights, occupational opportunities, and social mobility. Real cases illustrate the system's profound impact on individual lives. In 1728, José de Sevilla petitioned to join an apothecary guild reserved for Spanish ancestry. When colonial authorities discovered his baptismal record listed him among mestizos and mulattoes, Sevilla was forced to produce multiple witnesses attesting to his Spanish genetic heritage. The lengthy legal proceedings examined his physical appearance, marriage connections, and family history before ultimately reclassifying his ancestry. These bureaucratic practices created an extraordinary historical record. Colonial documents preserve detailed information about genetic mixing patterns, regional variations in ancestry, and the social dynamics surrounding racial classification. Modern genetic research can now compare these historical records with DNA analysis, revealing both the accuracy and limitations of colonial racial categories. But by the late colonial period, the system had become increasingly difficult to maintain. Genetic mixing had produced such complex ancestral combinations that precise classification often proved impossible. The system's ultimate irony lay in its unintended consequences. Rather than preserving Spanish genetic purity, the caste system created detailed documentation of how thoroughly European, Indigenous, and African genetic lineages had become integrated throughout Mexican society. The very mechanism designed to maintain racial separation instead recorded the emergence of one of the world's most genetically diverse populations. In 2013, a team of geneticists undertook the most comprehensive analysis of Mexican paternal ancestry ever attempted. Their study of 659 men from 10 different regions across Mexico would reveal genetic patterns that perfectly matched the historical record. The results provided unprecedented molecular confirmation of colonial Mexico's genetic transformation. Paternal ancestry showed 64.9% European lineages, 30.8% Native American origins, and 4.2% African heritage. These percentages represent the cumulative genetic impact of 3 centuries of the caste system's complex social engineering. European haplogroups dominated Mexican paternal lineages, with R1b constituting nearly 80% of all European genetic markers. Additional European markers, including R1a, I, and E1b1b, appeared at lower frequencies, suggesting diverse origins within the European immigrant population. The geographic distribution of these genetic markers reveals the strategic patterns of Spanish settlement. Northern and western regions showed European paternal ancestry ranging from 66% to 95%, corresponding precisely to areas of intensive mining activity and Spanish colonial investment. Central and southeastern regions displayed Native American paternal ancestry between 37% and 50%, reflecting areas where indigenous populations maintained larger demographic presence throughout the colonial period. Native American paternal lineages consisted primarily of haplogroup Q1A3A, representing 81% of all indigenous genetic markers. This finding confirms the genetic continuity between pre-Columbian populations and modern Mexican ancestry. The presence of additional Q lineages suggests survival of multiple indigenous genetic traditions despite massive population decline during initial contact. African genetic contributions, while numerically smaller, showed remarkably even distribution across Mexican regions. Haplogroups E and AB appeared in frequencies ranging from 0% to 8.8% nationally, with notable concentration in Jalisco at 8.7%. This pattern differs significantly from other Latin American countries, where African ancestry concentrates in specific coastal or plantation regions. The study's most striking revelation emerged from comparing paternal and maternal genetic patterns. While European ancestry dominated paternal lineages at nearly 65%, between 85% and 95% of Mexican maternal lineages remained indigenous, represented by haplogroups A, B, C, and D that had existed in Mexico for thousands of years. Modern autosomal DNA analysis confirms these uniparental genetic patterns while revealing additional complexity. Mexican individuals typically show European ancestry ranging from 30% to 50%, Native American ancestry from 40% to 60%, and African ancestry from 2% to 8%. However, individual variation within these ranges demonstrates the continued genetic diversity within Mexican populations. The genetic story of Mexico doesn't end in the colonial period. Today, scientists are discovering that this complex ancestry has created something remarkable, one of the most scientifically valuable genetic populations on Earth. The people who survived centuries of disease and upheaval weren't just lucky. They carried specific genetic advantages that helped them endure catastrophes that wiped out entire civilizations. These survival genes are still there, hidden in modern Mexican DNA, and researchers are just beginning to understand what they can teach us.